Right, I think we'll go ahead and get going. First of all, thanks everybody for joining this. It'll be a short webinar on the current state of the art of successful wireless deployment in student housing real estate. For those of you who haven't met me, my name's Andrew Marshall. I'm with Campus Technologies. I've been doing student housing networking since around 1998, and for a couple of decades before that in the general networking and technology industry, including working with some of the originators of the internet, such as Ina Steferout and Nathaniel Borenstein on the original ARPA project. So we bring all that experience to deploying successful Wi-Fi today. Just to qualify what we mean by successful Wi-Fi in student housing, what a student housing resident is looking for right now in student housing is that they don't have to think about the internet, either wired or wireless. It should behave like a utility. That is, it should always work and always be there. The expectation of a student housing resident is that they should be able to go to Best Buy or any electronic store, buy any device they care to think of, bring it back to their apartment, connect it, and just use it with nothing getting in the way, and not have to think about the service at all. That's quite a hard trick to pull off, but we can help show you how to do that. So the first question is, are your residents happy? Do they get that kind of experience? The reality is that maybe they don't. If they don't, they're complaining to you. They're probably in your front office complaining about the Wi-Fi doesn't work or the Wi-Fi is slow, and it can affect your renewal rate if you're not as good as other people in the market. There's three topics I really want to cover in this webinar today. One is wireless coverage across your property. The second is density. That's the amount of Wi-Fi you have on the property. And the third is management. That's how you manage the Wi-Fi deployment. Before you start thinking about putting Wi-Fi on a property, you have to start thinking about what foundation you're building that on. You have to have a good wiring deployment on the property, a good wired internet connection in order to deploy wireless successfully. The trick, and we always talk about the user experience or the UX, again, is that the resident doesn't have to think about that. It's a utility. They expect to be able to turn on a tap and get water in the same way they expect to be able to just use the internet. When you're wiring a student housing property, it really depends whether you're purpose-built or whether you're adaptive. But the best practice for wiring is to have a home-run Ethernet cable between each endpoint and a wiring closet. The best way of achieving that is to have a low-voltage design consultant work with you if you're building a new property and advise on the best way of achieving the wiring. I won't go too much into the wired network components now because we're really here to talk about the wireless. One important aspect of achieving that utility deployment is access, what we call access friction. What the resident doesn't want to have is anything getting in between them and being able to achieve the end result they're looking for. Generally, we don't want to impede them getting onto the internet. Now, there's a lot of things that can impede residents getting onto the internet in a student housing property. And these are some of the common obstacles that you may see in different deployments. If we can allow too many people to connect devices, it's going to slow the internet down. That's a common objection. Now, the reality is when you're designing a wireless network today, you should be designing for 20 devices per bed, wireless connected devices per bed. Now, when I tell people that, they say, you know, you're crazy. There's no way anyone can have 20 devices. That's just no longer true. If you think about the number of electronic devices a student housing resident turns up at school with, just the basics are going to be a laptop, a tablet, a smartphone, one or two e-readers, one or two gaming consoles. And now we have the Internet of Things starting to become real. So they probably have an Amazon Echo. They maybe have several Amazon Dash buttons, many, many other different wireless devices. So it's very important to plan for having many devices per resident and not put a cap on that. The second objection that comes up is that many networks, particularly on campus, want residents to register different devices Otherwise, they have no way of knowing what's on the network. You can't do that any longer. Student residents hate having to do a registration for every device they buy, and it creates a massive support burden for the network operator. We also run into a lot of situations where communities make residents log in so we know who they are, and if they have a virus, we can track them down. Your network management platform should be able to do that. There's no way you should have to get in the way of the resident getting a great user experience on the internet. Another objection is we should be able to identify when someone plugs in a device they shouldn't, which interferes with the network. Again, same thing. If you have a good management platform, that shouldn't be an objection. You really don't want to have all these obstacles like log on and registering MAC addresses get in between the resident and what they need. That's how you get dissatisfaction. Now, this is also an interesting one. We want to be able to slow down or turn off someone's internet access if they don't pay their rent. Well, if you're providing internet access as an amenity, I'm advised that it's not a very good idea to do this, because what you're then doing is make a connection between the rent and the internet access. And if for some reason you have an internet problem and the internet is out for a day or two, you don't want that same resident coming back at you and saying, well, the internet was out, so I need a rebate on my rent. You don't want that line being drawn between the internet and the rent payment. So that's friction. That's what we talk about. So you've got to have a good wired network. You've got to have a low friction network. You have to make the internet behave like a utility. So Wi-Fi coverage in student housing. What we're talking about here is making sure there's a usable Wi-Fi signal anywhere on the property. That's a fairly straightforward thing to do. It's a very well-trodden path from a technical point of view. And usable is the key, because you can deploy access points that have a lot of Wi-Fi signal across the property, but you need that to be usable. What do we mean by usable? Well, everyone's used to seeing the number of bars on a wireless device as indicating the signal strength, 5 bars anywhere down to 0. And these are the measurements that we use in a graphic. I won't go through these blow by blow, but our objective on a well-covered wireless network is to have every signal everywhere on the property in the top half of this chart. So 20 dB signal to noise and above. So 4-3 bars, somewhere around there. Also important to remember, the quality of a Wi-Fi connection. That's the quality of the connection, not how much signal you can see. Depends on 2 things. That signal strength, the coverage we've just been talking about, and the noise or the interference. What I mean by noise is any other device on the property that can be putting RF signal in the air that could prevent you from getting a good quality signal. So the difference between the two, that's a signal minus the noise, is a thing called SNR, a signal to noise ratio. And I'm not going to get too technical on this here, but that's the number we use to measure whether a wireless network is providing adequate performance or not. And we just talked about noise and interference, and of course I had a slide which covered what I just said. So the 3 key factors here: coverage, density being how many resident devices are served by a single wireless access point. Let's talk about that for a second. So we've talked about coverage, that's enough radio signal across the property. Density is a number of access points you have deployed. What many people don't realize is that a wireless access point is a shared device. So if you have one wireless access point and you have 10 residents using that wireless access point, in effect, logically, the performance of that access point is divided by 10. But of course, those residents have more than one device each. So the performance and the throughput, the theoretical throughput, is divided by the number of devices that's connected to it. So you may very well have a manufacturer come to you and say, okay, we're going to put this access point in a corridor. It's going to serve 4 units, 4 4x4s. And, oh yes, don't worry, it's got a throughput of 300 megabits a second. That's true on paper. In reality, in a deployment, that isn't how it works. You need to have a very, very good ratio of devices to access points. The more access points you have, the better everything is going to work. You also want to design it in such a way that you can add density without having to open the walls and run new wires as well. Third point is manageability. That's making sure that the whole system runs as one system and not just a random, unmanaged bunch of devices. I'll come on to why in a moment. So Wi-Fi management we just talked about. What we're really referring to there is that all these access points, all this wiring that's in your property acts as a single system. So if somebody is in the fitness center connected to wireless, walks down a corridor, goes up a flight of stairs, walks down another corridor, goes into their apartment, they've probably passed 10 or 15 access points. They need to be connected all the way on that journey through the property. Same works in outside areas, in pools, any part on the property, you should be connected to wireless without having to do anything to your device. The second thing here is that if an access point fails, it does happen, it's electronic, that the other devices turn up their power to cover that hole in the coverage so you still have a seamless experience. The third point is if new interference comes into play or other interference comes into play, that the access points know about that interference and tune the frequency that they're operating on and the power level they're using to minimize the effect of that interference on the users. Generally, there's a single device or a single piece of software managing each independent network. That's a proper managed network. Very few people deploy that. It's very common in the enterprise space. Any Fortune 500 company, you'd see this. But more and more now, it's becoming de rigueur in student housing as well. A very common solution that you will see, and this is particularly true if you're using what we call an MSO or a cable company to provide internet to your property. If you have a 200-unit property and you call the cable company, whether that's Cox or Charter or Comcast, whoever it is, and you say, I want bulk internet for my property, what they're probably going to do is use their existing coaxial cable they use to deliver TV to your property today and go into every unit and connect a consumer-grade router, wireless router modem, onto that coaxial cable. This is typically what you find in any single-family home deployment across the country from a cable company. The problem with that is that those access points are not managed. So every single one of those access points is fighting with all the other access points that it can see. They're probably set on the same channel, but there's no management platform that's managing those and orchestrating them into a cohesive whole. We call that internally a JBAP, or just a bunch of access points. Those access points really do spend an awful lot of time fighting each other. And a very typical symptom, if you have this problem, you'll have all these cable modems in your property. Signal will look good, but in reality, the experience that people have on the internet is extremely slow and extremely sluggish. That's because of a lot of retries happening, because of the wireless access points interfering with each other. Not a recommended way to go. In general, an internet connection or a wireless connection that's designed for a single-family home or multi-family environment will not work in student housing. So just to recap there, adequate signal coverage, adequate density, that's enough access points and installed in the right spots, and using enterprise-grade components. That's the same class of equipment that is used in any major company and fully managed. That's how you deliver a high-performance student housing wireless network. Now, we're particularly vendor agnostic. There's many manufacturers out there that make very competent equipment that will achieve these results. I often get asked, well, why should I spend $250 or $300 on an access point when I can go to Best Buy and buy one for $40? Well, it's true, you can buy one for $40, but the components in that access point you paid $40 for are very low cost, low reliability components. They are $40 components. In a $300 access point, they are much more expensive components. So the mean time between failure and the capability of an enterprise grade access point is much, much better than a standard off-the-shelf domestic consumer-grade access points. You really do get what you pay for in that regard. A great example of that is if you go and buy a very, very, very cheap car and open and close the rear doors several 100,000 times, the door will fall off. If you do the same thing on a Mercedes, the door will not fall off. In fact, it'll work pretty much the same on the last close as it did on the first. And that's the reason why in Europe all the taxis are made by Mercedes-Benz. So very, very similar example. Okay, we call this whole process added together a next generation network. It's not the way we've done it in the past. It's the way we're doing it now. And it builds a strong platform going forward for the future as well. It's very important to note that what we are talking about is a best practice for deploying a wireless network today in 2017 and for next year, maybe into 2018. After that, all sorts of new technologies are going to come along. There's going to be new wireless connected devices that maybe we haven't seen yet. We're starting to see one or two of those this year. There may be a new Wi-Fi technology coming along. There certainly are a couple that are in the pipeline. I really don't see any new radical wireless technologies in the Wi-Fi arena appearing maybe before 2020 in general use. You've probably heard a lot of people speak about the 5G wireless that the cellular carriers are deploying. That really won't have any effect on anything before 2020 to maybe even 2022. But there will be changes. It's very hard to forward look with this kind of technology. But the better the platform you have to start with, the more adaptable that platform is to start with, the better chance you have of avoiding costs further down the road and making your investment last longer. Although I don't really want to get too much into financials and specifics at this point. That's really it. That's all I had prepared to talk about. It's a little bit about campus technologies. We've been doing this for a long, long time, specifically student housing only since 2001. We're a very vendor agnostic company. We're not tied to any one particular vendor. We can do whatever you want. We're transparent. We don't have mystery meat contracts. You know exactly what you're paying for or what you're getting. And we're not locking you in with management contracts into multiple years. We firmly believe that if we're not doing our job, you should be able to fire us.